Hey fifth graders, it's Mrs. Tremblay. It is time for us to learn how to multiply mixed numbers. So you need your your Unit 3 packet opened up to page 5, lesson 5, multiplying mixed numbers. And it would really help, I think, if you had two different colors of a colored pencil. So I'm gonna use yellow and blue. You don't have to use those two colors, but any two colors will do. It's just easier to see where they overlap because of course we need to start with a visual model. And again, this is part of the fifth grade standards. You do have to know how to recognize the model of it, how to create a model of it. And it does deepen your understanding of where these standard algorithms that we learn come from. So if you don't have those items yet, go ahead and grab that, a pencil, two different colors of a colored pencil or crayon or marker, whatever works for you. Grab those things and come on back. All right, so we already learned an area model for just multiplying a fraction by a fraction. And you don't have to write this, but I just want to review really quick before we get started here. When you had a problem like 1/2 times 3/4, we learned that this can mean half of 3/4, right? So if we were to create an area model for this, here's one whole, right? And I want to find the area of like 1/2 times 3/4. So I'm going to put 3/4 on here. Multiplication is commutative, so if you flipped it around, it wouldn't matter. But here I have one whole, and I partitioned it into 4 pieces, and I'm going to show 3 of those pieces to show the 3/4. I'm using one of my colors. 1, 2, 3. So right now, this part right here is 3/4. Now I want to do half of 3/4, right? So I'm going to take this 3/4, and I only want 1/2 of it. So that means, honestly, if I want half of the 3/4, here's my 2 chunks of the 3/4. I only want this top part, but we are going to need to know how many rectangles this rectangle is cut up into. So I'm just going to draw my line all the way. And to show half of 3/4, I would only shade one of these 2 pieces I just drew. And this is the 1/2. So for 1/2 of 3/4, my answer to this is this chunk right here. Because this is 3/4 by 1/2, right? So if I want to know what the answer is, I want to know what part of the whole this is. So I have 3 pieces here, right? This one isn't double shaded. This isn't part of the 3/4. This is 3/4 by 1/2. And so I have 3 pieces shaded, and the whole is cut up into 1, 2, 3, 4, 5, 6, 7, 8. So 3/8 of the whole is shaded. So we're going to apply this model to mixed numbers. I know, doesn't it sound like fun? It just looks a little bit different. I mean, just trust me, it'll come with time, but yeah, I know everyone loves the standard algorithm, but this is where it came from, and these are standards you're required to learn, I promise. So here I have 1 2/3 times 3/4. And if I'm looking at area model, this basically means, like, let's say you have a rectangle that it's 1 2/3 by 3/4, and I need to know the area of that. Now, if this was like 5 and 3, we would just say, well, 5 times 3 is 15. Woo, we're done, right? This is a little different. So if you have 1 2/3 times 3/4, let's put this on there. I'm going to draw one nice big rectangle here. I want 1 2/3 times 3/4, right? So 1 2/3, let's see here. I need more than 1, don't I? So this right here shows 1 rectangle, so I'm going to make 2 instead. So right now this is 1, right? And now I need 2/3 of this other one. So I'm going to go ahead and cut this up into thirds, and I only need this little piece right here. So to show my 1 2/3, I would color this entire piece here. Here's the 1, and then 2/3 of this other one. 1 2/3. Okay, so far so good. This would be either the length or the width, because I could turn it the other way and make it that. It's commutative. Okay, so now I want this to be 3/4, right? So right now this side length, this is 1 whole, right? If this is 1, so is this. This is 1 whole. I only want my side length to be 3/4. So I need to cut this up into 4 pieces. And I only need 3 of those 4 pieces. So I'm going to go ahead and shade 3 of the 4 pieces. 1, 2, 3. Okay. So when we look at what's shaded here, or double shaded, like this is the 1 2/3, that's that side length. This is the 3/4. And we know we're dealing with a rectangle here. It's an area model. So my answer lies in here, right? So in the other one, we had to figure out, okay, well, how many pieces were in the chunk that's double shaded, right, with the length and the width. And we had to figure out how many the whole was cut up into. So for this one, it's a little tricky because aren't these pieces different sizes than those? Yes. So what I want to do is I want to get all the same size pieces, and see how this was cut up into thirds? All we have to do is just cut this one up into thirds. And boom, we're set. It's that common denominator, right? So I want to know what my answer is. So I'm going to look at how many pieces are shaded. 1, 2, 3, 4, 5. So 5, 10, 15 are shaded, or double shaded, because that's part of this rectangle. And your denominator is how many pieces the whole is cut up into. And this is where I see sometimes some struggles. The whole is not cut up into 24 pieces. This right here is actually showing 2 whole. This side length is 1, and so is this. So the whole amount is actually this piece right here. This represents 1 whole, right? I have 1 whole and then part of another one. So the whole square is cut up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. So my answer would be 15/12. And again, 15, that the numerator is how many pieces are double shaded. The denominator is how many pieces the whole is cut up into. And this one, I have more than 1 whole, so we only need to look at the whole amount. So 15/12, of course, is improper, right? So let's go ahead and fix this up. I know that 12 goes into 15 one time. And from 12 to 15, there's 3 left over out of the 12. And I'm hoping that at this point, you're looking at this saying 3 and 12. Oh, 3 divides into both of those. Let's simplify. And if you divide them both by 3, we would get 1 and 1/4. So that's your final answer. All right, let's try another one down here, but I want you to make a little change on your notes. It's 1 2/5 times 1 1/2. I only want you to do 1 2/5 just times 1/2. So just scribble out that, okay? Very professional, I know. So I have 1 2/5 times 1/2. So the first thing I want to do is draw myself a big old rectangle. And if I want 1 2/5, I'm going to cut this. I'm going to need 2, right? Because 1 2/5 is more than 1. So here's 1 whole. And now I need 2/5 of another. So I'm going to cut this into 1, 2, 3. I'm going to draw 4 lines to make 1, 2, 3, 4, 5 pieces. So 1 2/5 would look like this entire piece shaded, and then 2/5 of another. So here's the 2/5. So we have our 1 and our 2/5. This represents 1 2/5. Now I want to multiply that by 1/2, so I want only 1/2 of the 1 2/5. So on this side, I want this to be 1/2. So right here, I've got my 1 2/5 for my side length. Here I only want 1/2, so that means I need to cut this into 2 pieces, because my denominator's 2. And I only want 1 of those 2 pieces. I only want 1/2. So that would mean that only 1 of these 2 would get shaded. So my answer to this if I'm looking at the area model for my rectangle, it's 1 2/5 by 1/2. And we know for rectangles, if this is a half, then the other side should be half. And if this is 1 2/5, then that should be 1 2/5. So here's my answer. Now we're supposed to, for our numerator, have the number of pieces that are shaded, but they're the number of equal sized pieces, right? Do you see how this one right here is cut up into 10 pieces? 2, 4, 6, 8, 10. This one's not. So let's make those match. So I have identical sizes, right? So 1, 2, 3, 4. And now since we're dealing with all the same size pieces, we can go ahead and get our answer. So I see in this rectangle here that 1, 2, 3, 4, 5, 6, 7 pieces are shaded. And the whole is not cut up into 20. Remember that this right here is one whole. This is one whole. And so each whole is cut up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So the answer to this would be 7/10. And 7/10 is in simplest form because the GCF of 7 and 10 is 1, and dividing those by 1 is not going to do anything. All right, so now, how does this help us get the standard algorithm? Well, just take a look at what we did here. When we were trying to figure out the answer to this, for this first one, we had the 1 and the 2/3, right? But when we did this, these weren't cut up at first. We then cut it up, and didn't we just create 1, 2, 3, 4, 5 thirds right here? So again, why is it not 5, 6, and why is it 5 thirds? Because this is one whole. The whole is cut up into 3 going across this way. So we just took our 1 and 2/3, and instead of using the 1 and 2/3, we looked at it as 1, 2, 3, 4, 5 thirds when we were giving our final answer. So we took 1 and 2/3 and used 5 thirds instead. Are you noticing a relationship between these two? Well, 3 times 1 is 3 plus 2 is 5 thirds. Those are equivalent. Or maybe you said if it's 1, this one equals 3 thirds. And 3 thirds plus 2 thirds is 5 thirds. Yes. So all we did was we took this mixed number and we changed it into an improper fraction, basically. And if we take our 5 thirds times the other side length 3/4, 5 times 3 is 15, 3 times 4 is 12, and we get the exact same thing. Okay, so look at B. For B, this 1 2/5, we started off with 1 2/5. In order to get our answer, we then had to cut this up as well. We cut the whole up into the piece sizes so it would match. And instead of 1 2/5, we had 1, 2, 3, 4, 5, 6, 7 fifths. So we use 7 fifths instead. And 7 fifths times 1/2 gives you 7/10, which is that. So the moral of this story, all you really need to do, the standard algorithm, and you do need to understand the area model as well, okay? I'm not just telling you a lengthy story of information you don't need to know. You need to be able to recognize this and create this, but people just don't come up with standard algorithms. They use those visual models and patterns to assist them in understanding it, which is what I want to do for you. When you're multiplying mixed numbers by fractions, you just need to change the mixed number into an improper fraction, and then you do what we did before, okay? Just saying, well, there's a 1 here, and there's 1, and 2 times 3 is 6, and 3 times 4 is 12, so 1 and 6, 12 is 1 1/2. That doesn't work. You can't just multiply it in the form that it's in and get the correct answer. So when you're multiplying mixed numbers, you just need to change the mixed number into an improper fraction. Then you can multiply the numerators and the denominators as you did before. So these are the same 2 problems, and again, you gotta take that little 1 off. These are the same 2 problems as above, All right, so I'm just gonna go ahead and use this method and just resolve the problems that we did above. So if you see a problem like this, I would want you to notice, okay, it's multiplication. That means I don't have to get a common denominator like in addition and subtraction. I see a mixed number here. I need to change this mixed number into an improper fraction. And you can look at this 1 as 3/3 plus 2/3 to get 5/3. Or we saw that 3 times 1 is 3 plus 2 is 5/3 times 3/4. So I'm going to rewrite that problem. Now we just learned that you can cross simplify. So when you look at this, I know that 5 and 4, there's nothing I can do. But 3 and 3, those numbers are exactly the same, right? That means that the GCF is going to be itself. So I can divide both of those by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. I'm left with 5 times 1 is 5. And 1 times 4 is 4. And 5/4 is improper. When you give the answer, I want you to give me the answer as a mixed number, of course, in simplest form. So 4 will go into 5 one time. And 4 times 1 is 4, right? It's 1 away from 5, and our denominator doesn't change. So 1 1/4 is exactly what we got up here. Now up here, we didn't cross simplify to start. So we ended up with 1 3/12 and then had to simplify it. If you cross simplify first, you can go straight to it. Either way is fine. All right, so for letter B, we're hoping to get an answer of 7/10. I have 1 2/5 times 1/2. I'd want you to recognize, okay, I am multiplying a mixed number by a fraction, so I need to go ahead and change this into an improper fraction. 5 times 1 is 5, plus 2 is 7/5 times the 1/2. Now when I look at this and check out my diagonals, 5 and 1 I can't do anything with, and 7 and 2 I can't do anything with. So I'm just going to go ahead and multiply across the top. 7 times 1 is 7, 5 times 2 is 10, and I'm done. All right, we're only going to do this first page today. We'll finish the second part of this tomorrow. Thank you so much for watching. Have a great day.